Welcome to my algebra class. We are working with section 2.1 and we're going over the properties that we're going to use this year. The closure property says that a given set of numbers in an operation, the answers are contained in the set. For example, if I take any real number and add it to another real number, that number is a real number. For example, subtraction and the whole numbers would not work if I took 7 minus 9, I get -2, and -2 is not a whole number. So some sets are closed as long as the answer is in the set. Others are not. The commutative property you've seen for several years now. It's where we change the order of the numbers we're adding and we still get the same answer, and that also works with multiplication. So if I have 6 plus 3, which equals 9, I get the same as 3 plus 6. And it also works with multiplication, so 6 times 3 equals 3 times 6. The associative property, or the grouping property, says that you can add the first two numbers here and then the third, and you'll get the same answer as if you added the last two numbers in the first. So you can change the grouping of your numbers and you can get the same answer. For example, 6 plus 2 plus 3, that's 8 plus 3, which is 11, is the same as 6 plus the quantity 2 plus 3. 6 plus 5 is 11. And it works for multiplication also. 6 times 2 times 3 is 36, and 6 times the quantity 2 times 3, 6 times 6 is 36. You have to understand how many terms are in an algebraic expression. Terms are always separated by addition or subtraction signs. So for example, this mathematical expression only has one term because there's no addition or subtraction sign. The next one has two terms separated by one addition sign. So the terms are 3x and 7. The third mathematical expression has three terms separated by an addition sign and subtraction. The next term, because it's enclosed in a set of parentheses, it has exactly one term. And the last one, since all these letters multiplied together, since there's no addition or subtraction, again, it's one term. The properties of equality we're going to be using. Some of these you have already used in the past but never had a formal name for them. The first one is reflexive. I consider it the mirror property, or the reflecting property. It says that A equals A. In other words, what's on the left is identical to what's on the right. And this is used quite a bit in geometry. The symmetric property looks something like the commutative property, but it's an if-then statement, and it's switching around the equal sign, not around the addition or multiplication sign. So if A equals B, then B equals A, which means that if 6 times A equals 12, then it's true I can turn it around the equal sign, 12 equals 6A. And you have done that for years, like if you had a problem 3 plus 2 equals 5, you've turned it around, said 5 equals 3 plus 2. The transitive property, I call it the train property. It's a logic property. It says that if the first thing equals the second and the second equals the third, then the first thing has to equal the third thing. For example, if 5 equals 4 plus 1, and in turn 4 plus 1 equals 2 plus 3, then it must be true that the 5 has to equal the 2 plus 3. Find your paper for the assignment on page 46, oral exercises 13 through 25 and written 1 to 34. Make sure your heading is there, the title, fold the paper in half, and we're going to do the evens. The answers to the oral exercises are not in the back, so ask questions of me if you're not sure what the correct answer would be. So 13 through 25, they want you to name the property illustrated. Number 14, you do not have to copy the problem down. I'm going to do it to show you what's happening. So in this one, we can see that they switched the grouping symbols. The order is still the same, but the grouping symbols have been changed, so this is associative of addition. And you can use the plus sign. Problem number 16, look at in your book, I'll copy it here also. 1/5 of 15W is equal to 1/5 times 15 in parentheses W. Again, the order is exactly the same on the left and the right, but the parentheses have changed their position. So again, this is the associative property, but this time of multiplication. Number 18, we have 3 times the quantity 8 times 0 equals the quantity 3 times 8 times 0. Again, switching the parentheses, associative of multiplication. Problem number 20, if 3 plus P equals 12, then I can turn that around and say 12 equals 3 plus P. Because of the words if, then, and because it's switching around the equal sign, I know that's a symmetric property of equality. Problem number 22, you have 5 plus Q in parentheses plus a negative 3 equals in parentheses Q plus 5 plus negative 3. Now they haven't changed the grouping symbols, they still enclose the same thing, but they did change the order of the 5 and the Q. So this has to be commutative of addition. Again, you do not have to copy the original problem, just give me the correct property. 24 says there is only one real number that is the sum of 0.4 and 2.6. So they're adding two real numbers and they're getting a real number, and that is the closure property of addition. The written exercises, we're going from 1 to 34. Double check. Okay. So problem number 2, simplify. I want you to show work on these and put together, use grouping symbols and put together what you would add to get the answer easily. So I'm going to go for multiples of 10. So this is 850 and this is 50, which gives me 900. So you're to show me how you rearranged the problem so you could get to the answer easily. Number 4, I have 50 times 3 times 3 times 20. Well, if I put the 50 and the 20 together and the 3 times 3 together, that's going to be 1,000 times 9, which is 9,000. Problem number 6. Looking at it, I see 8 times 17 times 9 times 25. Well, the 8 times 25, 8 quarters is going to be 200. And then I have 17 times 9. So I get 200. Probably use your calculator if you want to on the 17 times 9. So that gives me 153 times 200. That would double the 153, which would give me 306 plus 2 zeros. So the answer is 30,600. Problem number 8. You have a couple mixed numbers and some fractions, and I would put together the ones that have the same denominator. Make sure you use 2 lines for your fractions. So 56 and 7/8 plus 1/8, that would give me 56 and 8/8, which is 57. And 4 2/5 plus 3/5 gives me 4 5/5, which gives me 5. So 57 plus 5 is 62. Problem number 10. You have decimals, find the ones that'll add up to a whole amount. So 4.75, I need a 25.25, so that would be the 10.25. Put those together. And then the 2.95 plus the 1.05 would give me a whole number. So adding these together, the 75 and the 25 make 1, so that gives me 15. And the 2.95 and the 1.05, the 5 and 95 make 1, add it to the 2 and the 1 makes 4. So that gives us 19. Problem number 12. The only thing you can do is collect like terms, and the only like terms you have are the numbers. So 4 plus 8 is 12. You cannot add the 9 to that since it's being multiplied by the z, which would have to be done first. So that's all you can do. 14, you have 5 plus 3w plus 2. Again, the like terms are the 2 and the 5, so I can add those together. It's 7. And the 3w is not unlike, it's unlike, so I can't add the 7 and 3 because I have to multiply by the w first. So that's all I can do there. 16, I have 3 times the quantity 4n. You can regroup and take the 3 times the 4 and get 12n. Number 18, we have 6m times 4n. So you can move the 6 times 4 together, and then the mn. So the answer is 24. Keep the variables in alphabetical order, 24mn. Problem number 20, you have 3p, 4q, and 6r, so you can move the 3, the 4, and the 6 together, and then p, q, and r. So 3 times 4 is 12. 12 times 6 is 72. P, Q, R. The next set of problems, we're continuing to do the same thing. Collect like terms. So 22. The 7 and 4 I can add together. So that gives me 11 plus x plus y. 24, I have 9m plus 2 plus 7n plus 3. Again, the variable parts are different, so I can't put those together. So I have 9m plus 7n plus 5. It's the only thing I can do to simplify that. 26, we have 8p plus the 3q. And then you have 96 and 4, which makes 100, plus the 87. So I have 8p plus 3q, 94 and, 96 and 4 make 100, so that's plus 187. $28, you can move the 5s together, and then times the 2, and then A, B, C, D. 5 times 2 is 10, and 5 times 5 is 25, so 25 times 10 is 250, A, B, C, D. And then the last set of problems, you are to name the property being illustrated. Number 30, they switch the grouping symbols, so that would be the associative of addition. 32, they have an if-then statement, so if 3.2 equals 8y, then you can turn it around and say 8y equals 3.2, so that is the symmetric property of addition. And then 34, if x equals -3, and then in turn -3 equals z, then it's true the very first thing, x, equals the last thing, z, and that's the train or the transitive property. There is no vocab check. on basic facts. So get help. Be sure and check your answers for the written exercises. And that concludes this video.